Great, thank you, Derek, and welcome everyone to this month's Connect with Remedy monthly webinar series. As we go through this session, if you have any questions during this session, you can ask them to our panelists in the Q&A area of the WebEx event. This webinar is being recorded and will be posted within a week of the live showing today, along with all the Q&A asked during the session. So to kick this off, we'll be covering Remedy-R9, configuring FTS in a server group environment. And today our presenters are Dolly Parrillo. She's a staff specialist technical support analyst with our server team, as well as Doug Reif, a principal tech support analyst with our server support team. I'll turn it over to you now, Doug.
Thanks, Greg. Hi, everyone. This is Doug. Thanks for attending the webinar today. FTS is a feature that really has solidified in version 9. It's faster and more stable than prior versions, and maybe you've noticed that. But because of this, most of the time that customers do experience a problem, it's really not a product issue so often as it's just a configuration issue. So our goal today is to make sure you know how to configure and troubleshoot your FTS environment. So the agenda for today is to do a brief overview of FTS, covering some of the features and functionality. We'll talk about configuring FTS, and then we'll focus on configuring for a high availability environment, as well as a disaster recovery environment. Then we'll spend some time looking at troubleshooting options that you have. And then we'll end with a summary, and we'll show you a list of references. Throughout the talk today, there'll be some knowledge articles and documentation that will be referenced at that page at the end. Then we'll follow up with a Q&A session. So to start with, Dolly is going to talk about some of the FTS features.
Hi, everyone. Thank you again for joining the presentation. Full text search has several components which we'll review in more detail throughout the presentation. We'll also examine the functionality of FTS, how it's invoked, the benefits of using FTS, along with an architectural diagram which represents how FTS works in a server group. As you can see from this slide, there's several components to FTS. The FTS license is a key component because you must have a license applied to be able to access the forums to configure FTS and for FTS to work as expected. If the server has a full text search license and the full text feature is configured correctly, full text searching is activated. With 9.1, the third-party utility used by FTS, the Lucerne engine, is built into AR Server. So when AR Server starts up, FTS is already active. The FTS configuration console is, as you would assume, one of the places where you will configure FTS. The centralized configuration is another component of FTS and is updated with the configuration changes once they're completed. The centralized configuration also allows you to review the configuration for every server in your group. We'll show some examples of the FTS parameters from the centralized configuration when we review FTS or configuring FTS later in the presentation. If you're running in a server group, you'll need to rank the FTS processor for the indexer in the server group operation ranking form. From Dev Studio, it allows you to define full text search properties for a form, or full text search and or multi-form search properties for a field. And lastly, the FTS Searcher plugin is used to perform searches from a non-indexing server in a server group. The FTS plugin provides row-level and field-level security for indexed data during searches. The FTS plugin supports the multi-form search used by applications such as RKM. The multi-form search uses a vendor form that displays an interface through which an application customizes the search to suit its requirements. And the search can return a specific list of fields, how the filters are returned, or terms that may or not be available in the document, and so on. It also permits you to specify the forms to search. And you can also tailor the search to target just the index data rather than all data. And lastly, we have the collection directory, which is a location where index files are stored, and the FD pending table from where the items are processed. We will review each of the components in more detail later in the presentation.
As Dolly mentioned, the FTS collection directory is a key component of the full text search engine. The location of this directory is defined in the central config as the full text collection directory. And if you go to that directory, you'll see what we kind of see here. This is an example on the Windows box. Underneath the collection directory, you see a bunch of directories that have numeric values. Each of these numeric values is the schema ID, if you're familiar with that. Every form in the system has a numeric ID. So each one of these numeric folders represents a form on your system. And underneath each one of those are the files that make up the collection. So in actuality, each form has its own index, basically. So we call that a collection. So each form has its own collection here. Another key component is the FT pending table. This table is the main job queuing for indexing. So every API call that reflects a change in FT index data writes to this table. In other words, if any activity performs an API call, such as users modifying a record, creating a record, or deleting, that API call, if it involves a field that has been FT indexed, will cause a record to be written to the FT pending table. And there is one record for each indexer server. So we're going to talk more about high availability environments, in which case you'd have more than one indexer server. So every time a record gets put into the FT pending table, one record for each indexer server would get put in here. Now this table stores a type of activity we call an operation, and those types of activities are listed here. So if a end user created a new entry that was indexed, then you'd have an operation type of 0. If they modified an entry, you'd have an operation type of 1. And one that we'll see a little bit later is the 5, which is a schema reindex. So anytime you do a full reindex or just a one-off form reindex, you'll see the operation 5 used. This is what the table actually looks like. You see we have the server name column. This column represents the server that actually invoked the activity. So in this case, whatever activity is represented by the operation type column, that was actually invoked by at the server called remprod1. You'll see here the schema ID and the operation 5. So this is actually a bunch of reindexes happening on all these various forms. So what I actually did in this use case was I performed a full reindex. And what that does is that for every form that has an index on it, it individually adds an entry into this table with the operation type of 5. Now, on the far right, you see the index server name, and there will be a row. In this case, there's only one indexer server. If this was a high availability environment, I would see each of these entries for each server. So I might see the row number 1 there with schema ID 2325. I would see it listed once for index server remprod1 and perhaps listed again for remprod2.
So this slide discusses the functionality of FTS. Keep in mind, FTS is transparent to users. If full-text searching is activated and the field is indexed for FTS, then FTS is used. FTS creates word indexes for short and long character fields, diary fields, attachment fields, and table fields. With some special considerations for attachment fields, the full-text feature can index any content where the character set is compatible with AR Server's character set. If AR Server is running as a Unicode server, the full-text feature has no restriction on the encoding format of the data content. You can therefore index and search content in multiple languages. And during a word or phrase search, the FTS engine finds requests that contain the specified word or phrase in the field. It also uses stemming to search for common variation of word stems. For example, a search for the term index returns requests containing index, as well as indexes, indexed, indexing, and so on. A QBE search, which stands for Query by Example, is simply performing a search by filling out fields in a form that are FTS enabled. Any workflow that invokes a search will cause AR Server to use the FTS search engine. When you perform a global search, you are searching multiple forms using defined rules, and the matches are returned from multiple sources. There are several benefits to using FTS, and they're listed here. One of them is FTS is much faster than the native database when searching long text fields. It's the only method for searching text within attached documents. It improves search performance by searching large volumes of data. It can define how the server interprets wildcards. The search results are ranked based on their relevance, and it also provides case-insensitive searches for case-sensitive databases. So FTS is invoked in two ways, indexing and searching. The indexer is invoked with each API call that changes data. Every time you create, edit, delete, or save a record, it invokes the indexer and updates the index. The indexer is a mechanism that makes data on a record up to date with the current data. The second way FTS is invoked is from searching by either performing an FTS search or a multi-form search. A full-text search is invoked through users performing a manual or ad hoc search, and a multi-form search is invoked from a global search. Any workflow that invokes a search will cause AR server to use the FTS engine. The server uses full-text searches when executing queries during workflow that have full-text index fields in the qualification. Global searches are performed using the RKM knowledge search, the landing console, or the BMC Remedy-R9 multi-form search. So this screenshot demonstrates an FTS search on a field that is FT indexed. Out of box, there's very few full-text index fields. We added full-text index properties to the incident ID field and did a search for all incidents. Here we can see the results of our search for INC with the %sign. The search will bring back all incidents up to the defined max entries per query limit. You'll also be able to see the incident number, owner, summary, status, and so on in the results. So the AR system multi-form search, or MFS form, serves as an interface or API for the BMC Remedy AR system applications to be able to perform searches on multiple forms within the system. If you search from a global search field, such as RKM search, or the global searches supplied by ITSM applications, MFS search is triggered. From the landing console, you would enter the search criteria and then click on the magnifying glass. From the RKM knowledge search, again, you enter the search criteria and then click on the magnifying glass. With either MFS search, you can choose the advanced search option and refine the search if desired. From advanced search, you can select or deselect knowledge sources, include or exclude words, search by date range, company, operational or product categories, business service or visibility groups. Both MFS and FTS are querying the same indexes, but how they return the results differ. MFS searches across multiple forms and fields, while FTS search does not. This slide demonstrates the results of a global search for the word RAM from the RKM knowledge search. The search also results include the summary field that you can see here, and it returns results from different forms and sources. So here we have an architectural diagram of a single indexing server in a server group. The indexing server contains the collection directory, which is identified here as FTS index. The processor, this index processes the data and updates the indexes. From the example, you can see the server has, server 3 has created or updated a record, and it's being placed in the FT pending table for processing. The FT pending table is identified here as the FTS queue. The search requests from the remote AR servers in the server group are routed to the primary FTS searcher via the searcher plugin process and connect on the secondary FTS port. And next we'll discuss configuring FTS. So configuring FTS consists of the FTS configuration console, the FTS tab from the server admin console, the centralized configuration, server group ranking form, Developer Studio, and FTS Searcher plugin. All of the settings defined for FTS will be found in the centralized configuration once complete, and you can also define form and/or field properties for FTS or MFS via Developer Studio. And lastly, the FTS Searcher plugin is used by the non-indexing servers to search. You can access the FTS configuration form from the server admin console. Simply go to System, General, and the FTS configuration. So this screenshot demonstrates configuration for an indexing server. The FTS configuration console is a vendor form and it's accessed via a plugin. You use the FTS agent box to enable or disable the FTS plugin processes in the ER monitor file. If you select this checkbox, the FTS process or the FTS plugin processes are automatically uncommented in the ER monitor file. And as you would expect, if you clear this checkbox and save the changes, the FTS processes are automatically commented in the AR monitor file. You want to make sure the FTS agent is enabled. The server configuration option consists of single server, which is used for a standalone environment, the server group indexer, which is used for the indexing server, and then lastly, the server group searcher, which will be used for the non-indexing servers in a server group. You want to begin your configuration of FTS with the indexer, and we'll set the server configuration option to server group indexer. If you select the server group indexer option, the indexer server name field under reader is unavailable because the indexer server name is not required for configuring FTS on the indexing server. If you're using something different than the default of 9977 for the secondary FTS port, you'll want to enter that in the FTS port field. The max JVM memory field defaults to 3 gigabytes, but if you wanted to increase that value, you would do so here. You want to make sure the path to the collection and configuration directories are correct and point to the local server. The path to the FTS and collection directories as well as the full text mode are written to the AR config file. The entry for the secondary FTS Java process along with the entry for the heap settings are written to the AR monitor file. The settings defined for FTS will be found in the centralized configuration once it's completed. This screenshot demonstrates configuration for a search server. As with the indexing server, you want to make sure the FTS agent is enabled. You'll select the server group searcher to configure the server as a search server or non-indexing server. If you select the server group searcher option, the max JVM memory field under reader is unavailable because from the search server, you must connect only to the reader instance running on the indexing server. And next, you'll enter the indexing server name and FTS port if different from the pre-populated default values. You must log into each server and configure FTS using the FTS configuration form. You must restart AR server for the changes made to this form to take effect. And you want to ensure that the collection and configuration directories are available on a local drive of each indexing server. You'll also want to confirm the paths of the collection directories and if collection and configuration directories are identical on each of the servers in the group. As with the indexing server, the entries are written to the centralized configuration and synced with the AR config file. From the centralized configuration, you'll find the values defined for the FTS configuration as well. From this configuration or from this example, we can see that the server is an indexing server and the path to the collection and configuration directories are local. You can view the settings for each server from the centralized configuration. The AR monitor config file from the indexing server will contain an entry for the secondary FTS Java plugin process. This process is used by the remote servers to search indexes in the collection directory. There should not be an active FTS Java process on search servers, and if for any reason you needed to increase the Java heap setting for the secondary FTS Java process, you could set it in the AR monitor file as well as the FTS configuration console as mentioned earlier. The FTS tab is accessed from the server admin console and it allows you to find various settings for FTS. From this tab, you can disable or enable FTS indexing or searching by simply checking or unchecking the box. But by default, the indexing and searching are enabled. You would only need to uncheck the box if it was selected and disabled previously. This tab is also the location from where you will initiate a full FTS reindex. And the collection and configuration directories are displayed here, but they're not configurable from this tab. Some of the other parameters defined on this one are the full text search threshold, and this sets the maximum number of search results returned from the search engine, and the default value for this setting is 10,000. Some customers have found that reducing the number to 500 has yielded better performance, but there is a trade-off where less results are returned. You'll need to decide which option works best for your environment and needs, but you may want to consider reducing the value if performance is an issue. The indexing failure recovery interval defines the number of minutes the server waits between attempts to index entries it failed to index in a prior attempt. The default value is 60 minutes and has been found to work best. The temporary table threshold is used during the processing of search results. The server creates a temporary table if the number of FTS matches reach the defined value of 200. If the number of FTS matches is less than this value, the server uses a SQL in operator for a query on an existing table. The complex search threshold is used during the process of search results, where the server combines results from subqueries to arrive at the final result. If the number of rows created during processing exceeds the default value of 1 million, the server returns an error message indicating the search is too complex. The indexing server group signal delay sets the number of seconds before a signal is sent to the server that owns the full-text indexing operation. When a server is not the owner of the indexing operation and generates indexing work, that server signals the server that is the owner of indexing. To reduce the frequency of signals sent, the signaling is conducted on a delayed basis. When indexing is generated, the server checks whether a signal is pending. If so, the server doesn't need to take any action. If a signal isn't pending, the server creates a pending signal to be sent in a specified amount of time. The default setting for this is 10 seconds. The next option is for case, and that defines whether full-text searching is case-sensitive or insensitive. Next, we have the search options, and this defaults to query unchanged, and this defines how the server modifies qualifications received from the client. This setting specifies if we'll have leading or trailing wildcards added to the search string. And the option for FTS and workflow controls whether the server uses full-text searches when executing queries during workflow that have full-text index fields in the qualification. The ignored words list, it defines words that are ignored during indexing. And the multi-form text search allows you to find relevancy for the following items: the title field weight, environment field weight, and/or key field weight, keywords field weight. These settings define the relevancy weight for the title field, environment field, or keywords field of a form in a multiple form search. For any of these options, a value of 1 is the baseline and provides a slight boost to the relevancy weight. If you leave the field empty, the weight defaults to 1. And if you want to increase the weight, you'll enter a positive number greater than 1. And to decrease the weight, you'll enter any number from 0.9 to 0.1. And if you want to see a significant difference in the relevancy score, you'll need to increase the weight by increments of 100 or more. And then next we have a screenshot of the Ports and Queues tab. And the queue used by FTS is 390602. This queue sets the number of indexer threads, and out of the box it defaults to a minimum and a maximum of 2 threads. When you find additional queues, as we did in this example, you must assign corresponding RPC program numbers, and you must define the minimum and maximum number of threads for each queue that you're using. If you're a large environment and you're encountering performance issues with 9.1 or records are not processing in a timely manner from FT pending, you may want to consider increasing this to a minimum of 2 and a maximum of 4, as we did in the screenshot. Here we have an example of the FTS Searcher plugin from the centralized configuration. This allows you to change various settings for the secondary FTS plugin from one centralized location. From this screen, you can change the port number if needed, the value for num core threads, as well as the configuration for logging. This is where you enable the debug level logging for the plugin, but there's some other settings that need to be changed to enable FTS debug logging, and Doug will cover that later in the presentation. You'll notice in this screenshot, the num core threads are set to 10. We do recommend that you should increase the num core threads for 9.1 from 10 to the default, or to 10 from the default of 5. And several settings are found in the plugin server configuration from the centralized configuration. And here we see an example of the sync changes from our previous screen. You could also change parameters from the centralized configuration if you wanted. You can change settings for every server and every plugin from the one centralized location. And when ranking servers in the server group, the primary FTS indexing server should be ranked 1 for FTS, and if a secondary indexing server exists, it should be ranked 2. Only the index server should be ranked in the server group operation ranking form.
Okay, you can use Dev Studio also to configure some components of FTS. So this first example is a form, the HPD help desk form. I'm looking at the form properties, and you can see here that you can configure some MFS settings. This is underneath the full text search section, and you can set up a schedule for indexing join, vendor, and view forms. So AR Server doesn't know when backend data has been changed on a join, vendor, or view form, so the only way it can reindex the data is to do it on a scheduled basis, and that's what you can set here through the form properties in Dev Studio. Now let's look at the field properties. So here I have clicked on this notes field, and you can see on the right-hand side, the field properties under database, that this field is indexed, the index for FTS parameter is set to MFS only. In the example we showed earlier where we did a query on this field, we actually changed this value to FTS and MFS. So those are the two primary sections of Dev Studio where you can configure some aspect of the full-text search engine. Now let's look at configuring specifically in a high availability environment. In the diagram here, you can see there's two servers at the top, server 1 and server 2, which are, in this case, they're back-end servers, and they are both indexer servers. And the FTS indexer component is the built-in full-text search engine, the Lucerne engine that's actually built into the AR Server Java virtual machine. And then the FTS searcher is the secondary plugin. So in this case, we have two servers that each have their own independent full-text search index, which is the collection directory. Then you have AR Server 3 and several more, which are defined as server N. It could be server 4, 5, 6, and 7. So all of those servers automatically would perform a search and connect directly to server 1 because it's the FTS rank number 1 in the server group operation ranking form. So all the searches would automatically occur against the first ranked server. Now if that server went down, the searches would automatically, if you follow the dotted lines, be sent over to the full-text search plugin on the second ranked server, which is server 2. When multiple indexer servers are used, those servers typically should be non-user facing, and that's just because indexing can be resource intensive. The indexer piece uses the built-in full-text search engine, and then the searches use that secondary plugin. So let's look at how to configure this. It's actually fairly simple. First thing to do is to make sure that FTS is currently working properly. Don't try to add a component to your HA environment without first making sure that everything's working. So make sure that searches work properly, make sure that indexing is working and keeping up. And then once that's true, you can configure a new server as an indexer. So as Dolly mentioned, you would use the FTS configuration page, you'd enable it, and then you would set it as the server group indexer. You can check the rest of the settings and make sure they're accurate and save that. Then the only other thing you really need to do is go to the ranking form and add this new indexer as the second ranked full-text search engine. That's all the configuration you need to do. Once you perform a reindex on this new server, and once that reindex is complete, you will now have an HA environment. At that point, once the indexing is done and this server is caught up, if the first server were to fail, then queries would automatically get redirected to your new HA server, and it should be seamless to the end user.
And now we'll take a look at some failover scenarios. FTS will fail over under the following scenarios. AR server is down, it stops sending a heartbeat, and it's not available to search. And second, the primary FTS indexer, AR server is performing a reindex and is not available to search. In these instances, the indexing and searching will fail over to the secondary or the next ranked server. The following screenshot demonstrates how FTS fails over automatically. As you can see from the slide, the second FTS indexer automatically takes over and searches are now routed to the server rank number 2 in the server group operation ranking form. Indexing continues normally on the secondary server, and the entries for the first ranked server are stored in the FT pending table and they're processed once the other server is available. And now let's take a look at disaster recovery options.
So the whole purpose of disaster recovery is to avoid risk during a catastrophic loss of your primary data center. So the assumption here is that your production environment is completely inaccessible. Configuration will be based on your specific needs. So we'll provide a few examples here, and you'll have to kind of decide what is more applicable to your environment. Regardless of the reason for recovery, the full text collection data must be recovered or rebuilt, as you'll see later, in order to support global search operations. Because every company has specific guidelines for recovery and specific requirements to enable global search capability within Remedy, the options provided here represent potential solutions which may or may not be applicable to your company. We do make an assumption that the database is replicated in near real-time manner such that the copy on the recovery site is as close to 100% as possible. And this is usually accomplished with database replication. So we're going to look at three options here. One is the isolated index, where the disaster recovery environment has its own FTS collection. Second one is remote collection directory, where a production server indexes files that are inside the disaster recovery environment. And the last one, remote FT index server, is where a server that's in the disaster recovery environment is actually a part of the production server group. So option one, isolated index. This is a very simple recovery option. When recovery has been initiated, the BNC Remedy-R system in the recovery environment is started up in the usual manner. After the system is up and ready, the Remedy administrator will trigger a full FTS reindex. Now this includes clearing out the FT pending table, removing all the files from the collection directory, and then performing a full reindex. The benefits to this is very simple, easy to maintain, easy to set up, but the caveats is because you have to perform a full reindex after the recovery took place, there will be a delay for end user before they can perform a full text search. Option two, the remote collection directory. You would set up an AR system server as an index server for FTS. You configure this machine as an indexer but not as a searcher, so the server will index data but really wouldn't do anything else. You configure this server to refer to a remote-mounted file system that's located in the recovery environment. Your production server, this indexer server, is actually indexing files into the recovery environment. In the recovery environment, you would set up a machine as an indexer whose indexes also are located in the same place. And this server will be used for indexing and searching only when the recovery environment site is in use. The benefits to this are that FTS collection is always being updated. It's dynamically updated, so it should be pretty much intact as soon as you're ready to fail over to your recovery environment. The only real caveat to this is if your recovery environment is geographically remote to the production environment, there may be a slow wide area network. So it's possible that the collection directory is not absolutely fully up to date when the failover occurs. And if that's the case, there may be some small time frame before they're fully in sync. The third option is what we call remote FT index server. You would add a server to the production server environment, but it's actually located in the recovery environment. This server will be in the recovery environment, but it's part of the production server group. This server is solely an indexing server and won't be handling any other kind of traffic. So you'd set up this auxiliary server in the recovery environment, so it's also in the recovery environment server group. It's actually a member of both server groups. In the case of recovery, this server would continue the role of maintaining the index in recovery. This was kind of a quick overview, but all of these scenarios and how to set them up are fully documented, and there's actually a page in the reference section, so if you'd like more information on this, afterwards when this webinar is posted, you can look at the references and you can read up on that.
When troubleshooting FTS, we want to investigate the following areas. Is the configuration set correctly? Were any changes made to your configuration? Are any errors being written to the log files? You'll want to review the FTS-related logging as well as the error log. Want to check the date and timestamps of the files in the collection directory. Are they current? Do the log files show any signs of corruption in the collection directory? Want to review the FT pending table. Are there a large number of records in the table? Doug will review some examples of errors seen in the log files and how to address them later in the presentation. When you troubleshoot configuration, check to make sure that the FTS agent is enabled. You also want to verify that FTS searching and/or indexing have not been disabled. You want to confirm the heap size is set appropriately for your environment and needs. Verify there are no errors in logging related to the heap space. Leading wildcard searches are the most expensive type of search you can do within Lucerne. Variables such as the number of unique terms in the index and the number of unique terms that end up matching the pattern can have an effect on the amount of system resources needed to resolve the query. If your users are using leading wildcard searches, you may want to consider increasing the heap setting for the secondary Java FTS process, but you'll need to make sure you have the resources available to do so.
All right, now let's look at some logging. One of the key logs that you can use is the AR-FTS log. Now this log is enabled by default, but it's enabled at a info and warn level. And to get a lot of value out of it, we often change it to a debug level. So in order to do that, you would have to edit the file called logback_server.xml, and you would change the 3 sections that are listed here from info and warn to debug. Now, once you do that, you do have to restart AR server for this to take place. So in the next few slides, when you see the value that comes out of this type of logging, when you do troubleshoot your own problems, you'll have to make a determination, is this the right log for me, and am I willing to restart AR server in order to get that log? So let's look at some of the examples of how you can use this log. This is an actual excerpt from the AR-FTS log from the searcher server performing a global search for the word RAM. And you can see a bunch of information here. I wanted to highlight some things. You can see the search schema IDs and field IDs. You can see here that schema ID 1865 and all the field IDs that were searched. You can also see it searched 2325 and a bunch of fields. I truncated this, but this is going to be actually the list of all the forms that are involved in a multi-form search, as well as all the fields that are involved for each form. So this gives you a very clear information about exactly what was searched when you perform the global search. You see some more information here, but one thing you notice is the max to return is 500. In this case, the threshold was changed from 10,000 to 500, so once this query returns, it'll only return a maximum of 500 records. And at the end, you can see the actual query did return 4 results. So this is really good information when you're trying to troubleshoot an issue where an end user performed a search and they believe that they found the wrong results. It tells you exactly what was searched and how many results were found. Now here's another example, a snippet from the same log file from a searcher server where we were performing an FTS search, not a global search, but again for the word RAM. And here the full text search queried a specific form and fields, and you can see the exact search criterion that took place. Again, later in the file, you see the max to return was still 500, and it returned 2 results. So again, this is really good information to try to identify exactly what search took place when a user might complain that they're getting the wrong results. The AR-FTS log also records a request to perform an index. So in this case here, a user created a new incident. In this case, it's incident 6. And when they created that incident, there's a bunch of fields in that form that need to be indexed. And so you'll see here from that log, it tells you exactly which fields were requested to be indexed. So if you're working on a case where you feel like a particular data isn't being found, maybe a search should have returned incident number 6 and it's not being found, one thing you can use this log for is to say, look, in fact, this record was requested to be indexed. A little later we'll show you the actual indexer log to see whether or not it actually was indexed. Most of the other logs you can enable simply by going to the Log Files tab from the Admin Console. So we're going to show an example here of using API, SQL, and full-text index logging. Now here's an example of SQL and API logs doing a global search for the word RAM again. So you see the API call was a get list entry with fields, which is a standard query, on the AIR system multi-form search form. Now that's the form that always gets used when you perform a global search. Now, a global search doesn't actually perform any SQL, but the SQL log does give you some information. So if you look here, the begin transaction, it says it's using the AR FTS plugin, and then it says phase 1 found 4 entries. Phase 1 is the actual search. So the raw data was searched and found 4 entries. And then you see phase 2 returned 2 entries. Phase 2 is where permissions and row level security are applied. So even though there were actually 4 matches, based on this user's particular permissions, he was only able to see 2 of those entries. And you can see all that using the SQL log. Now here's an example of the SQL and API log again, but this is doing a combination search between an FTS and a database search. So an example here might be a QBE where the person types in RAM into a FT indexed field, and they put in the word unable in a field that was not FT indexed, so it's going to have to perform a database search. So here we see the GLEWF again, the standard query on the HPD help desk form. You'll see the FTS search request for schema ID 1454. So this is performing the full text search portion first. When you do a combination query, we first do the full text search portion. Now that search found 2 entries. Those 2 entries are then passed into a database query. So the next line, the with AR SQL, you'll see this is the database query. If you look at the where clause, you'll see where, and you'll see the particular database field we had to search for the word unable. And then you'll see the and C1 in, and the C1, of course, is the request ID. The full text search query earlier returned a list of request IDs, returned 2 of them. So here you'll see C1 in, and it lists both request IDs. So that shows you how a full text search is passed into a database search so that you get a combination of the results. And all that was available just with the API and SQL log. Now let's look at the full text index log while performing a reindex. When I perform a reindex, you'll see some special keywords in here. You'll see I made a little bit larger there the word global reindex. This is showing that the log knows that a full reindex was requested. And then you'll see 35 forms. You'll see that total number of forms 35, and that's because there are 35 forms on the system that have an MFS and or an FTS index on one or more of the fields or the form. So 35 fields then will be shown here. I only showed a snippet, and each of those will be individually indexed, and this log will show all that activity. So one thing nice that you can glean from this log is now you know exactly how many forms that you have to reindex on a full reindex, and you also know exactly what their names are. Here's an example of just reindexing a single record. From the same log, the full text index log, performing a reindex of one record, you'll see here the schema ID is the same throughout, 2822, and you see all the different fields. Each line is showing you a different field for that form is being indexed, and you'll see this is a join form. If you look here, the entry ID is a number with a pipe and then KBA and then 102. So this is showing that whatever form this is, it's doing an index of one record for all the fields on that form, and that's clearly shown in the index log. So it's a very useful log to identify what exactly is being indexed, and you'll be able to see, in this case, the process completed. So I'll actually see the success for that record as well. Another log you might look at is the plugin log. So this is the ARFTS plugin indexer log. And in here, it's not often you'll look here, but there are times when there's a problem. Indexing isn't working right, maybe searching isn't working right. And so you'll look at this log, and here's an example of something you might find. This example here shows an error getting index searcher. Likely cause is index does not exist. Read past end of file. Now that error typically means that there's something wrong with the collection directory. It probably means there's corruption in your files. And this is one place that you would find that out. So use this log. If you're having problems with just things aren't behaving right, this is a good log to look at to see how the indexing is working and if it's reporting an error message. So talking about collection files, maybe getting corrupted. So some things that you can use the collection files for when troubleshooting are, one, look at the size. Often people think that the size of the collection directory is inappropriate, but you need to know that Lucerne uses an algorithm that prefers speed over size. It cares about speed more than it cares about size. So the size can actually grow very large because it's trying to work as fast as it can to index stuff, and it believes that if I don't have to worry about size, then I can go a little bit faster. So during a heavy and intensive operation like a full reindex, you might see the size grow very large. But there is ongoing housekeeping that will try to catch up. It'll try to coalesce and defragment data. So over time, you might see the size go back down. Periodically, if something very large is indexed again, you might see the size go back up. So I think it's important to know that the size can be large and the size can change. So just be aware of that behavior. Also, as I noted in the indexer plugin log, corruption can occur. So for example, maybe the indexer is writing to one of the files and the server just simply crashed. Maybe the operating system had a problem. It simply crashed while writing a file. That can happen, and it can leave one or more files corrupt. That often requires a reindex. And I mentioned earlier, a full reindex or a clean reindex often means cleaning out the FT pending table, deleting the contents of the collection directory, and then doing a full reindex. If you have identified that only one form is corrupt, then it's a lot easier for you. There's a knowledge article that we list in the references later on that tells you how to index a single form. So you can go in and delete out the collection directory to remove the corruption and then index that one form. So if you have that experience and you need to do that, take a look at the references later on. Here's another example of if you do have corruption, how it might be seen in the full text index log. So the full text index log, the name is actually by default is arftindex.log. And in here again we see the cannot close index root exception, read past end of file. So it's another indication that you might have corruption. You can use the FT pending table to do a certain amount of troubleshooting. You can kind of get an idea of the status of the indexing by looking at the contents here. By looking at the table, you can get an idea of what indexing is taking place and if it's keeping up. It's if you had thousands or tens of thousands of rows in here, it might be difficult to understand what you're looking at. So I've included a couple SQL statements here that might help. So the first one, we'll do a check for queued jobs based on the server that triggered the job. And now I gave you some very simple examples. What I'd recommend is you take these queries back to your environment and run them and see what you get. In my example, for this page and the next one, my example is very simple. I went to both of my servers and performed a full reindex. That's all I did. So in my example, this shows you that from server name remprod1 and from server name remprod2, I did something that caused 35 records to be written to the full text pending table. And you know, based on what we've seen earlier in the slides, those 35 records represent the 35 forms that have an operation type of 5. So this shows me here, from the invoking server, Remedy-Prod 1 and 2, how many jobs were requested. Now, if I look at this next query, this shows me, based on the indexer server, how much work they have to perform. So this query is slightly different. It's based on the index server name column. Now this shows me that regardless of which server requested it, remprod1 has 35 jobs in queue to perform, and so does remprod2. So in your environment, you might have 2 or 3 indexer servers, and you might have thousands of records. These two queries will really help you identify who invoked the work and which indexer server has yet to do the work. Sometimes what this might help you identify is that maybe you have one server that's having a hard time keeping up. Maybe one server has a count that's 1 or 2, or a very small number, it's keeping up, but the other server isn't. So it'll help you identify that, and it'll help you focus your attention when troubleshooting.
The following references provide additional information on the topics covered in this presentation. You'll also find a great deal of information related to FTS in our online documentation.
So this ends the webinar. We hope this webinar has given you some good exposure to full-text search configuration and troubleshooting methods. If you are having trouble searching or indexing FTS or MFS data, first check your configuration and then look to the logs for more help. Use the provided references to help begin your investigation, and of course, contact support whenever needed. And that's it, and we'll start the Q&A session.
Great, Doug. I do have several questions lined up here. Just a reminder to our attendees, if you do have a question, please feel free to use the Q&A section of the WebEx event, and our panelists will address it. The first question I have, Doug, is why does support recommend to not use a shared drive /NFS for collection directory?
Okay, good question. In general, and for some of you that have been around a while, you might know that this wasn't always the recommendation. And so what we found over time is that we've seen issues with indexing and keeping up with indexing when it was a remote file system. The Lucerne engine really wants to have a file system that's as close as possible to the engine itself. So when you're doing that over a network, there's always a delay. We have customers that have a very fast network, but there's always a delay relative to a local file system. So if full-text search engine was a RDBMS, a relational database, you probably wouldn't question whether a relational database would have a local file system. You would never have Oracle in general with a remote file system. Similarly with FTS, you really don't want to have the actual files that are being saved on a remote box. So we feel like it performs better and is just going to have less problems if it's local, so that is what we recommend.
Great, thank you. The next question I have is your references mention how to index a specific form, but is there any other way to index without having to perform a full FTS re-index?
That's a good question. Tools provide you, so out of the box, you have the tool that you have is the button to do a full reindex. You are provided a tool that's in the knowledge article about how to reindex a single form, and that tool is not on a GUI. You get to go to use the driver tool and initiate a query. So it's not something that you click a button, but it is something you have available to you. Anything other than that, indexing a form or indexing the entire system, is going to be kind of ad hoc and as needed. Now, because every index request is a record in the FT pending table, it stands to reason that you could manually insert records in the FT pending table and create your own job, ad hoc. So you can do that. That's about the only other method that I'm aware of is manually editing the full text pending table.
Great, thanks. Is there a max memory setting for the FTS JVM max memory setting?
The XMX setting that you see in the AR monitor config file is the max. There's not a say a theoretical limit or a physical limit to that. Most of the time, Dolly had mentioned that using a leading wildcard can cause the memory to grow huge. And so we have customers we know they require leading wildcards, and we know their memory gets very large, and we have seen them set the XMX size to over 10 gigabytes, and they've been able to perform the searches, and because they had enough physical RAM on the box, everything seemed to work fine. That's not typical. Doing leading wildcard searches is very expensive, so more often than not, customers try to encourage their users to not use a leading wildcard, in which case the memory requirement would be much lower than 10 gigs.
Great, thanks. Okay, the next question is, does the upgrade to 9.0 update the collection directly automatically as part of the upgrade process? Or is the collection directory and files associated with 8.1 reusable for 9.x? The customer is just wanting to evaluate the time it will take for him to upgrade.
Okay, that's a good question. That is a big part of the upgrade to 9.x is doing that conversion. The conversion is actually a file level conversion, so it doesn't the utility that converts the collection from the old format to the new format, and the old format being there was one collection for everything, and the new format being a single collection for each form. It's significantly different. It's stored differently, they're not compatible. 9.0 cannot use the old format, and 8.1 can't use the new format, but the conversion is done at the file level. So the utility actually goes into the collection files themselves and converts them. It doesn't look at the FT pending table or which form and fields have been indexed. It simply does it at a file level. So some customers have asked, they don't know how long it will take to do the file level conversion, but they do know how long it takes to do a reindex. And so they said, well, what if I just delete the collection directory during the upgrade, and once it's done, I'll just do a full reindex? Yeah, that's valid. In our testing, we have found that actually doing the file conversion is much faster, and that's why we included that method in the upgrade. We believe, and we've tested this over and over again, we believe that the best idea is to let the upgrade process convert the files at the file level, and then once you're done with the upgrade, anything that was left in the FT pending table will now automatically be indexed using the new format. So hopefully that answers the question.
Great, thanks. Let's move on to the next question here. For 9.1 centralized configuration, there is a new entry in ar.cfg for configuration-name. Inside a server group, should each server group member set configuration name to a specific server group member, for example, server 1, or should each member set the configuration name value to itself?
What we like to see is that the configuration name is the same as the server connect name, because we already know the server connect name is going to uniquely identify that server on the network. That the configuration name needs to uniquely identify that server. So it's because the server connect name already does that. Quite often the configuration name will be that same value. But the configuration name does need to uniquely identify each host individually, and so using the host name, short or long name, is probably the best idea for that.
Great, thanks. I just have 2 other questions lined up, so this is just a friendly reminder. If you do have a question, please use the Q&A section of the WebEx event. I'll go ahead with the next question. What is the recommended FTS threshold setting for ARS 9.1?
Well, out of the box, it still comes with 10,000, and Dolly talked to this a little bit. 10,000 is actually considered, it's a safe number. So it'll return a bulk of the results. Typically, we're not expecting users to find more than 10,000 matches. That's a lot of matches. So anything higher than 10,000, if we picked a number like 50,000, we know that it would be likely to be a performance hit, and likely a user's not going to be able to do much with 50,000 records anyway. So 10,000 it's a safe number. It's a lot of records to, if the user actually returned 10,000, it's a lot. It's too many to consume. But at least they're more likely to find exactly the data they're looking for. Quite often when customers tell us that they have performance issues doing full text searches, we recommend drop that number. Now 500 is a number that we've used in our examples here, and 500 is a pretty low number. It's a drastic enough change where we often see a significant improvement in performance for those searches, but it's also possible that your users are not finding all the data that they want. So the magic number is probably somewhere between 500 and 10,000. Again, out of the box, we set it to 10,000 because we think that's a safe number. But if you're having performance issues, we do recommend that you drop that number to something lower than 10,000.
All right, this next scenario or use case is kind of long, so if you need me to repeat it, please feel free to, have me repeat it. All right, so for customers who want to stop using FTS, disabling indexer and searcher via checkboxes on server information FTS tab. The result seems to be that records are still written to the FT_pending table. Records pile up in this table in large numbers. It seems like disabling only stops the indexing of records in table FT pending, but does not seem to stop records from being created in table FT_pending. What is a good way to prevent this from happening other than disabling FTS on all form fields one by one?
Yeah, there's a sort of an easy but difficult answer to this. The easy answer is that you need to remove the full text search license. Now, I say it's difficult because if you have performed an upgrade, you may know that the upgrade checks to see if FTS is working, and that's one of the things it wants. So if you use our ITSM products, our ITSM suite, the ITSM suite has functionality that requires the full text search engine to be used. So if you're using ITSM, we want you to be licensed and we want FS to be working. But if you have made the decision that you don't want to use FTS, or maybe you're not using our ITSM products, you can simply remove the license. It's really the license is the key that states whether or not fields that are indexed for FTS will write a record to the FT pending table. So that's really, you can, maybe in a test environment, you can experiment with that, remove the license, and see if that's giving you the results that you want.
Great, thanks for that answer. Next question is, how can I determine how long a reindex will take, and how can I monitor the progress of the reindex?
Another good question. There's actually a knowledge article on how to estimate the time for reindex, and I should give you a caveat right up front. If you've seen that article or used it, the article makes assumptions. It makes an assumption that you're processing at a certain rate. The knowledge article can't know what the rate is, so you have to identify your own rate. Now, how you identify the rate is by looking at the ARFT index log. If you turn on the full text index logging and you perform a reindex, you can look at the entries in that log, and you can identify how fast the indexing is going. Now, often what you'll find when you look at that log is that the full text search engine can index at a rate of, say, 2,000 items per second. When I say items, I mean an item would be one field on one record on one form. So one form might have many, many records and many, many fields, maybe you have 30 fields. But if you're talking about one form, one record, and one field, that one item, the full text search engine should be able to index those at a rate of at least 2,000 items per second. And so if you glean that information out of your log and you know how many it's running per second, then the trick is now to identify how many items there are to process. So that knowledge article looks at every form on your system and sees how many fields are indexed, how many forms are indexed, and it also does a count of the records. So it knows exactly how much data there is to index. The one piece that it doesn't know is that if you have table fields that are indexed or attachments, it really won't know how large those are. So that knowledge article does a pretty good idea of giving you an estimate other than table fields and attachment fields, and those there's just no way to estimate. You'll have to figure that out based on real-life experience.
All right, Doug, can you hear me now?
Yes.
Okay, very good. I had some busy signals that I heard, so sorry about that. Okay, the next question is it possible to have one or more FTS servers indexing/searching the same index?
We don't want that. Now, whether it's possible or not, between the file locks on the collection directory, I would say it's not a good idea to do. When we recommend one indexer, now some people that have been around a while may recall that we in versions past, we have had that scenario where we had multiple indexer servers set up to write to one collection directory. We have found that to be problematic, and we no longer recommend that. We recommend one indexer per collection.
Great, thank you. I have two more questions lined up. If we archive data and run an FTS search, will it search the archive data/form?
Now, that would be a question as to whether or not the archive form had included FT index fields. And I don't know right off the top of my head if our applications do that. If you build an archive form of some form that you have, by default, I believe that new form, if everything is behaving correctly, will not have FT index fields, and so you would manually have to add the FTS or MFS property to those fields to ensure that they would be searchable. If if you were archiving a form that was a knowledge source and you wanted a global search to find it, then you would have to also add it as a knowledge source. You'd have to add the archive form as a knowledge source as well.
Great. Okay, and we are down to our last question. So this is kind of a last call for questions. So attendees, if you want to get your question in the last moment, please use the Q&A section, and I will ask it live. So Doug, the last question that I have is, does the max entries returned by git list affect the results returned in an FTS search?
It doesn't affect the number of records that the full-text search engine will find in itself, but it will affect the number of records returned to the API call. So within AR server will perform the search, the FTS search, and it might find 2,001 records, and then the max get list is set to 2,000. So only the first 2,000 will be returned to the end user. So yes, it is affected on the results that are sent to the end user, but it doesn't affect how many records the full-text search actually will find.
All right, another question did come in. Do we have to re-index FTS if we enable a field to be FTS and MFS only?
No, when you make a field modification, whatever the field modification was, whether it be changing that from MFS to MFS FTS or even just removing the index, any of that type of work, I had mentioned earlier that API calls where a user added a record, deleted a record, that would create a record in the full-text pending table, the FT pending table. What I didn't mention was that admin operations do the same thing. An admin operation where it changes the field properties also will create an entry in the FT pending table automatically, and that will perform the reindex automatically. So in the case where you had a field that wasn't indexed and you added an FTS MFS index, an entry would get put in the FT pending table saying to reindex that entire form for that field. It'll index every row or every record in that form for that one field automatically.
All right, I do have another question. It's kind of long. Again, if you need me to repeat it, please let me know. If the local DB for ARS is case sensitive and FTS is applied to additional fields to allow for case insensitive searches on those fields, at what point do you think switching database products makes sense? This is in terms of index size and performance.
That's a really tough question. We've had many customers that had to make this decision. We had customers that were on Oracle with case sensitivity, and they had to make a decision whether they wanted to use Oracle case insensitivity, FTS, purely FTS, or perhaps switch to SQL Server. Now, honestly, I've had customers that had done a lot of testing on Oracle and eventually went to SQL Server because they just felt like going to a database case insensitivity on an environment that was primarily case insensitive was the right way. And we've had a lot of customers that are using Oracle case insensitivity as well. So there's really not a right answer. In general, I think we would believe that if the database could handle the case insensitive part of the search, that's probably best. The full text search engine gives you a lot of capabilities outside of purely case insensitive searches. You know, full text search engine gives you the word stemming and allows you to look, do an index search on large character fields and attachments. There's a lot of functionality in FTS that you get outside of case insensitive searches. When the database provides the case insensitivity searches, that is usually going to be more robust and more, it's more streamlined. It's built into the database. So I think the answer is if you can go to a solution where the database provides the case insensitivity, that's probably the better option. And if that means going to SQL Server, that might be a huge decision for you, but that's a decision that each company is going to have to make. FTS does provide case insensitive searches, but then you also have to index all that data, whereas in the database, it's already in the database. You don't have to do anything additional to support the case insensitive searches.
Great. Another question is, we currently have 3 ARS servers in our environment, 1 admin and 2 AR user-facing. FTS indexing is set on each server. Is this advisable?
Well, as you saw on one of the slides, we do recommend that FT indexing be on a non-user facing server. It can be because of performance, typically because of performance. We like to have an indexer server that has enough horsepower on its own to be able to keep up with the indexing and the searching. Now you can do that. You can have a searcher or an indexer on the user-facing servers, but you'll just have to make a decision whether or not that's affecting the performance of the end users. In general, we believe that the end user performance is the most important thing. We want end users to be serviced quickly. And so if that means taking some component off of the user-facing servers, then we want to do that.
Great, thank you. One more question here. When indexing, when will indexing happen on a form? When any field which has FTS enabled is modified, or any field which is not indexed is modified?
If you have a record that so I'm assuming we're talking about data modifications here. So if you're modifying a record and you modify data that is not FT indexed, then it won't cause that record to be reindexed. It should only cause a reindex if data for an indexed field has been modified.
All right. So at this time, Doug, thank you very much for the Q&A session. There are no further questions to be asked. So at this time, I'd like to turn it back over to Greg. Go ahead, Greg.
Thank you, Steve. And just wanted to thank Doug and Dolly for this presentation today, and everyone for attending. Standard contact areas via social media or via the web, email, and our toll-free number are listed now. And again, thank you for attending our program this month on FTS. This will be published within a week of today's live event, along with the Q&A that was asked live as well as in the panel. Thanks again, and thanks everyone for participating.